Hi everybody, welcome back to my channel. So last three classes, okay, we are finished the last three classes and we are discussed 30 questions regarding three-phase induction motor. Today also we have to discuss 10 important questions regarding three-phase induction motor. Okay, so we can start with the 30 last classes. We are discuss the 30 questions and then today 31st question. If the rotor input of a squirrel cage induction motor running with a slip of 10% is 110 kilowatt, gross power developed by its rotor is in kilowatt. So you have to find the rotor output. The rotor input is given and the slip is given. That is a 10%. So option A 10 kilowatt, option B 90 kilowatts, option C 99 kilowatts, option D 80 kilowatts. So rotor input it is 110 kilowatt and slip is 10 percentage. Okay. So there is a power flow diagram. You can see you have to find the gross power. Gross power means that is the power in output of the rotor. Rotor output it is also known as a gross power. The equation is 1 minus S into P2. We have already discussed this one power flow diagram and we are done some problem regarding this power flow diagram. So okay. So 1 minus S into P2. This is our equation. We need this equation. 1 minus S into P2. P2 is the rotor input. It is a given. S is the slip. That is also is given in the question. So it is a easy. So rotor input is given 110 kilowatts and by equation you know rotor output is equal to 1 minus S into rotor input. So slip is 10 percentage means when you are changing to the value is 0.10. So rotor output is equal to 1 minus 0.10 into rotor input. 1 minus 0. So rotor input is 110 kilowatts or 1 this in the watt value. Okay. Itna so rotor output will be 0.90 into this watts, 110 kilowatts. Okay. So when you are multiplied by the 0.90 into 1, you will get the 99 kilowatts. Okay. 0.90 into 11 lakh watts. Sorry. Yes, 11 lakh watts. Okay. 11 lakh watts will be there. 110 kilowatts means 11 lakh watts. So 0.90 into 11 lakh is equal to 99 kilowatts. So what will be the answer? So answer will be option C. Your answer 99 kilowatts. So rotor input it is given once again. Rotor input is 110 kilowatts. By equation rotor output is equal to 1 minus S into rotor input. So S will be 10 percentage or 0.10. So rotor output will be 1 minus 0.10 into rotor input. So it will be zero point 0.9 into 110 kilowatts or 11 lakh watts. You will get the 99 kilowatts. Okay. So there is a next question. If the slip of the rotor is doubled, the value of rotor reactance per phase will be option A reduced to half, B doubled, B 4 times not changed. So that already we discussed one question. So you know that running reactance is equal to S into standstill reactance. That is a equation now. When the rotor reactance is, so you can see that rotor reactance that will be the running time. Rotor reactance is directly proportional to the slip. Okay. So when the slip is doubled, what will happen? Rotor reactance also will be doubled. Okay, that is only this equation you need. X2R is equal to X into X2. So answer will be B double. Option B will be the answer. So the next question, the shape of the torque slip curve is parabola, hyperbola, rectangular parabola, straight line. So what is the torque slip characteristics? In x-axis you can see the slip and the y-axis you can see the torque. This will be the graph. Okay. So that will be ns and n will be equal. That time slip will be torque will be 0 like that. This will be the graph. So it is also the same as rectangular parabola. So parabola you know that this shape. Okay. So this will be the parabola shape, but it is known as a rectangle, almost same as a rectangular parabola. So answer will be rectangular, not hyperbola. Hyperbola is not like that. Parabola not is a rectangular parabola. It is like Torque slip characteristics is an important question. Okay. So there is a next question, 34th question. For a higher efficiency of a three-phase induction motor, the slip should be large, very large, as small as possible, none of these. So I am going to simple one explanation. You know that rotor copper loss is equal to slip in the rotor input. You are already studied from the power flow diagram. Rotor copper loss is equal to slip in the rotor input. So when the slip is increasing, what will happen? Rotor copper loss will be increased. So loss is increasing means what will happen? Efficiency will be decreased. So it's a one way of explanation. You can explain various conditions using the various condition. I am using this method. Rotor copper loss is equal to slip in the rotor input. If the slip is increasing, what will happen? Copper loss will be increased, efficiency will be decreased. Okay. So what will happen? The for the higher efficiency, what will happen? Slip will be very small. So you can make it is as small as possible. So slip is increasing means what will happen? The losses will be increased. So you have to reduce the slip. That will the slip value should be as small as possible. So option C is the right answer. The next question, the upper bar in a double squirrel cage induction motor have option A higher resistance and higher reactance, high resistance and low reactance, low resistance and high reactance, low reactance and low resistance. So this already discussed in the last video. I think you remember that one. So that is will be the figure. So you can also this will be the double cage. There is a upper slot and is a lower slot. So upper slot having upper cage having high resistance and low reactance. So it will be used in the starting condition. You need the higher resistance in the starting condition to make the high starting torque. So the upper part will be high resistance and the low reactance. So answer will be high resistance and low reaction. Option B will be the answer. Okay. During the one of the following test on induction motor, reduced voltage is applied. Load test, no load test, block rotor test, star resistance test. So there is a four test is given. During the one of the following test on induction motor, reduced voltage is applied. So you know that in the induction motor we are conducting two tests. One is no load test and other one is uh, blocked rotor test. Okay, no load test means you are giving the rated voltage. So that is not a reduced voltage method. But here blocked rotor test of induction motor we are finding the copper loss. So what is a copper loss? It is the I square R loss. So in this condition rated current should be flow through this winding. So rated current should be flow through the winding. So uh, what will we do? So you will make a rotor as a blocked condition like a short circuit condition, and we are giving applying the voltage. So you know that when the short circuit condition, what will happen? When you're giving the small voltage, what will happen? The rated current will be flow. So it is a short circuit condition. So current will be flow very high value when you're giving the small value of voltage. So when you're giving the low voltage, current will be become the rated value. So in the following reduced voltage when you're applying the blocked rotor test. Now load test it is a we are applying the rated voltage. Okay. So current will be very low. Load test and starters is not regarding this induction motor. So answer will be blocked rotor test. Okay. The 37th question, short circuit test on induction motor can be determined. Short circuit test, what is a short circuit test? It is like a block rotor test. It is used for finding the copper loss. That will be our answer. Option B will be the answer. The next question, torque developed by three-phase 400 volt induction motor is 100 Newton meter. If the applied voltage is reduced to 200 volt, the developed torque will be. Okay. So first condition we are giving the 400 voltage. That time what is the torque? It is 100 Newton meter. Second time we are applying only the 200 motor. 200 voltage means the voltage is reduced. This time what will be your torque? Option A 50 Newton meter. Option B 25 Newton meter. Option C 200 Newton meter. Option D is 62.5 Newton meter. So you can go through the question. So you know that you already studied torque is directly proportional to the voltage square. That is already discussed in the last video. Okay, so the starting torque is directly proportional to the voltage square. Okay, so the next. So first time what is a V1 is a 400 voltage and T1 that time what is a torque 100 Newton meter. The second condition, what is the voltage is 200 volt and the torque is what is you have to find the what is the torque. So 100 volt is directly proportional to the T is directly proportional to V square. So 100 is directly proportional to the voltage square. And second condition, torque is you don't know, it is unknown value is directly proportional to voltage square. When you're taking the ratio, so 100 divided by T2 is equal to 400 square divided by 200 square. This is a 400 square. Okay. So T2 will be equal to 100 into 200 will be become here. Okay. 200 square divided by 400 square. Okay. So T2 will be equal to T2 you can change to here this one right side. So 100 into 200, 100 into 200 divided by 400. So 100 into 200 square means 200 into 200 divided by 400, 400. So 0, 0, there is a 4 0 upper hai, 4 0 denominator mein. Okay. So that is a cancel. It's a 2 into 2, it is a 4, 4, 4 cancel. Then 100 divided by 4 will be that will be answer 25. So when you're calculating, it will be 25 Newton meter will be your answer. Option B is the right answer. Okay, this is an important question. It's also one important question. Normally, you can see in the multiple choice question exam. So next one is the starting torque of a three-phase induction motor has maximum value. The rotor power factor is a tricky question. So you have to understand one things that one. Okay, so slip is maximum. So you know already studied that for the slip is maximum slip for maximum torque S will be R2 divided by X2. So when the R2 divided by X2 there is a one value that will be equal to slip, that time you will get the maximum torque. So slip at starting time. Starting time, what is the slip? S is equal to 1. You know the starting time N will equal to 0. So slip will become equal to 1. So the question you can see then starting time it has a maximum value. So starting time the rotor torque has a maximum. So starting time R2 starting time slip is equal to 1. So slip is equal to 1 means R2 by X2. So the starting time R2 is equal to X2. Okay. So R2 is equal to X2. You can see that there is an impedance triangle. You can see this is a resistance, this will be reactance, and this will be the impedance. So R2 equal to X2 means you can see this side. So when you're taking this angle, adjacent side is equal to opposite side. Adjacent side is equal to opposite. That means this angle will be 45 degree. So it is used to your for tan 45 is equal to 1. You know that tan 45 is equal to 1 means x2 divided by tan 40 tan 5 equal to tan 5 matlab kya hai? Opposite side by adjacent side. So x2 by r2. So it is a when your the angle is 45 degree, what will happen? R2 become is equal to x2. So here it is a condition that R2 is equal to x2 means the angle will be 45 degree. Okay. So what is our power factor? What power factor is equal to angle between R by cos of R by Z. So angle between R and Z. So what is the R component is the Z component. So is the angle. So it is a power factor angle. So cos y will be equal to cos of 45. It is equal to cos 45 means it's a 1 by root 2. It will be 0.707. So induction motor is normally inductive. So answer will be power factor will be 0.70 lag condition. That is a one tricky question. Okay, it's normally not seen, but is a higher objective exam. Higher exam, you can see this question. So when the starting time torque is maximum, so the rotor power factor will be 0.70 lag. Okay, that will be your answer. And the next 40 questions. In an induction generator operation, the slip is always positive, negative, infinity, 0. So what is the induction generator? That you have to understand. The induction generator, or it is also known as a asynchronous generator, is a type of alternating current. That means AC, electrical generator. So it is producing the electrical current that uses the principle of induction motor to produce electric power. So induction generator operate by mechanically turning their rotor faster than the synchronous motor. So when your induction motor is there, so when in the induction motor rotor is running below the synchronous speed. So when you rotate by some mechanical arrangement, you are rotating the rotor by greater than the synchronous speed. So normally when you're considering the 4-pole machine, the synchronous speed is 1500. So normal condition, rotor is rotating 1400 RPM. By using some arrangement, you are connected to a rotor you are running greater than the 1000, normally it is running 1400 rpm, you are making it is a running greater than 1500 rpm. Okay, so n will be, so that is the rotor speed will be greater than ns, so it is will be become 1500 is an example. So what will happen, this value will be higher value, what will be the slip, slip become negative means ns is a 1500, it will be sometimes it is a 1600, so minus 100 will be there here, so slip will become negative. So in the induction generator the slip always will be negative value. Okay, so these are 40 questions. Okay, uh, so and the last 10 question we are will discuss